What we're looking at in this video is how images are stored on computers. So if you think about an image, then that's analog data, that's a picture, and if you think about what computers use, they use binary. So we need to work out a method in which we can get an image stored as binary. And so the first thing we do is we take an image, and this is Big Ben and the House of Parliament. And if we blow it up, we can see exactly how it's made. So each image is split up into a grid, and on that grid there are small elements, small blocks which make up the picture, and that's just one block which we've got there. And these blocks are picture elements, so the elements that make up a picture, and the word which we use for them from picture elements is pixels. So that is one pixel which I've got there, and this is another pixel here. So a small square on an image is a pixel. So the question is, how do we do these? And so let's take a look at this. This is the pixels which make up an image, which is a house with a bit of smoke and a sun. And so what we do is we use binary to represent each of those colours on the grid. And so here I've said that the yellow colour will be 0, 0, and the blue colour will be 0, 1, and the red colour 1, 0, and the black colour will be 1, 1. So each of those numbers represents the colour, so then I can tell my program and I can tell the graphics card exactly how to represent that picture because it knows what it is in binary. And so if we look at the data which I need to store for that, here's the data which I need to store to represent this here or to translate to this picture over here. Now, in addition to this data here, I also need to tell it the width of the picture and the height of the picture, and also this thing here, which is like a key, which we call the color depth. And so once I've told it the color depth and I've told it how those colors are being used, if I tell it the width, which is 1, 2, 3, 4, 6, 7, 8, 9, 10, so I've got 10 pixels on my width, and my height is 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So my height down here is 16 pixels. So I need it to know that there's 10 pixels and 16 pixels in height, and I need it to know the color depth is these 4 colors and they correspond to whichever colors they correspond to. And then I have the data which describes the picture itself. And this is the basis of how bitmap images are stored on computers.